Okay, problem number 9. A rectangle is inscribed under the graph of y equals 16 minus 2x squared, so that one side is on the x-axis. Well, here's the dealio. You should probably understand what this is actually talking about. So we're saying, well, that was a bad line. We are saying this. Well, that's bad too. Where's my little blob? There we go. Alright, boom, boom. And that function, y equals 16 minus x squared. One of the functions x squared, the negative flips it upside down, the 16 bumps it up 16. So that's going to be an even function. Boom. That looks just like that, except not really because that was a bad one, but you know, something like that. And we're being told there's a rectangle that has been inscribed underneath this parabola. Now what that means, inscribed, we're saying that the two upper endpoints of this rectangle are actually physically on our function there. And then the base of this rectangle is sitting on the x-axis like that. So think about it like this. This point in the corner right here has some unknown x value and some unknown y value, which we're going to label as such. Now think about this. My drawing is not to scale. The right side should be the same as the left side. It doesn't look like it is. Sorry about that. But I do know that from the middle, from the origin right there, over to that endpoint, is a distance of x, because it's going from 0 to x. Well, that point right there is going from 0 to the x value of negative x. If you want to be super strict, we could write that's the point there. So that's also a distance of x, which tells me that the base of my rectangle is 2x. Cool, 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 cool. Well, what's the height of the rectangle? Well, the height of the rectangle is going from the y value of 0 on the x-axis up to that unknown y value. But here's the deal. We know that that y value is on that blue function, y equals 16 minus x squared. So instead of writing y for that height, I can substitute in that expression, 16 minus x squared. Because I know that point is on my graph, and that's the equation of my graph, and that point has an x value of whatever the x value is that we use. That's sweet. So let's write ourselves an area equation. Area equals length times width for a rectangle, so it's going to be 2x times the quantity 16 minus x squared. So graph time, we want to find the maximum area, the maximum rectangle we can inscribe in there. So that means we need to graph this function. It's going to be cubic. Ask yourself why. And once we graph that function, then we can calculate the maximum value and go from there. So I'm going to let you find your own window on this one, but once you do, you're going to get a graph that looks something like negative x cubed graph, which means it's going to look something like that. That's cool. Look, knowing the other functions is actually pretty helpful. And we want to find that maximum value because we don't care about that thingy because negative land doesn't exist in the real world. So let's find that maximum value. And then the x value is quite literally going to be that x value right there. And then we can substitute into our function 16 minus x squared to find the corresponding y value there. Then we can have our dimensions and find our area. Alright, so my bad, I just noticed that I dropped my 2 there, so it should be 16 minus 2x squared, 16 minus 2x squared in that equation too. So when you find that maximum value, you should find an x value of 3.266. The y that I'm writing here, y equals, I'm talking about this point where the y values are actually talking about the area. So the area equals 34.8 10.837. And then I want to know what this y value is, which is the height of my rectangle. So plug in 3.266 into 16 minus x squared, and you will get that the height of that rectangle is 10.667.